Welcome, everyone. On behalf of One Business World, I'm thrilled to host today's session. I'm still processing the incredible scale and depth of our recent event in New York, which has truly become the place to go for the energy industry over, I would say, the past 5 years. Last year, we had Secretary of Energy Chris Wright with us, and this year we hosted the Grid System Czar of the United States, Michael Pessin, alongside the top movers and shakers in the energy space. And Rich Deming was a guest at this very event. Because his insights are so vital, I wanted to bring him here today to make his knowledge available to all of our global followers who could not be in New York in person. Rich is the founder of CEO and founder of Third. And today we are looking at how specialized intelligence is reshaping capital decisions in climate assets. Welcome, Rich.
Great to be here. Thank you.
Yeah, Rich, when I look at the climate asset space from a more private markets perspective, the gap between, I would say, the great concept and then the viable assets is quite massive. And I always look at carbon capture, the technology behind carbon capture, which absolutely works, of course, but scaling is still challenging, and it's a point where you need to scale it in order to then reduce CO2 globally and meaningfully, and that requires massive capital, of course. It requires engineering, it requires flawless execution, and you spent over 2 decades developing exactly these things, owning, operating substantial renewable power projects before you founded Third. And if I understand this correctly, you built this platform out of sheer frustration with these very execution barriers, if you will. And what were the specific bottlenecks in your own career that then convinced you a software solution like this might be a good solution?
Well, it's interesting you bring up carbon capture in my other role in life, which I've done for 25 years, is as you mentioned, renewable energy development. And when you say carbon capture, we've tried to figure out carbon capture at our biomass power plants, and we've gone way down that road and spent money and looked at tech and had our engineers look at it. And the thing that always stopped us was that there was no long-term offtake of revenue. So no matter what you did, you didn't know when you got to the end how much money you'd make. So how can you justify the expense? And every difficulty cascaded back from that. And the reason I zero in on that so quickly is that that's kind of the whole point. I mean, to get something done, anything done in any industry, you have to know where the money is coming from. And if the money is going to come from a market, it has to be a pretty darn sure market, or nobody wants to make that investment. So that's what you're trying to do, is you're trying to stack up the different parts and pieces to get a project done. And everything that is in your way between you and that cash coming to the bank is going to cause problems. So the first thing is, what are your offtake agreements? Are they valid? Are they bankable? Are they executed? Do they last for long enough to pay back the capital? But then there's a million little roadblocks in the way of that, and that is will you get to the point that offtake agreement goes into effect? Because do you have the right permitting? Do you have the right operations and maintenance set up or team in place? Do you have every little part and piece? And there are hundreds of parts and pieces, and any one of those can cause a project to fail. And so it's a tricky puzzle to put together. And you are right, because really, once I got to a point where I didn't we've got a great crew down at East Energy, and I don't have to work as hard every single day. And so when I started to get that extra time and started to think about this phase of my career, it was really about, like, what is the thing that I would like to solve for? And so, you know, over, in 2005, the first little solar panels I put up on a biofuels station. There were permitting issues, and then a little 10 kW solar project, and there were financing issues, and there was a tax credit involved, and it was hard for everyone to figure out, even though it was a tiny project. Um, and then fast forward to 2024, and now I'm closing two different projects at $70 million each. And it took about a year and a half when it should have taken 3 months. And it was just mind-boggling that the same things that had happened throughout my career continued to happen. We would sign a term sheet. This is the classic. You sign a term sheet, and then things get complicated. They take too long to get complicated, first of all, and then things start happening. And it's, well, we found this little thing we didn't understand, or this contract clause, et cetera. And so you just get into this bind that you didn't need to happen if everybody had clarity from the beginning, about exactly what the project was, and exactly what the document set was, and exactly what the risk factors are. Everybody doesn't have to waste their time. They can just pursue projects that will work.
Right. And you see that in construction, of course, all the time. As you say, it's not different 2005 than 2024. And see it in Washington right now with these construction sites, right? That wait for continuation.
Hmm. Yeah, it's funny you
Um,
say that. My career up until 2005 was construction. And so I come from a background of development and construction and building mid-rise apartments. And then I pivoted to clean power in about 2005. I wanted to work on something that I felt would have more meaning for me. And so there are similarities in the roadblocks.
Yeah, I mean, my background is asset management, and I look at the current macro environment, and of course, there is a lot of noise around AI, and there's a noise around energy, and there's a fascinating intersection, if you will, right? But there are also a couple of red flags, I would say, and I'm highly skeptical personally when it comes to the sheer scale of these data center build-outs we are seeing right now. When you look closely at the numbers, you notice that there's a lot of dependency on these two big frontier models, the LLMs from OpenAI and Anthropic, which are widely unprofitable companies at this stage. So
Mhm.
earning billions of dollars. And at the same time, the actual timeline to clear that generation queue, if you will, get the power projects online is stretching out longer than ever. I think I saw the latest numbers like one of these things will go live the first time in 2029. And even if they say, oh, we just built a data center with one, I don't know, gigawatt, it's only 500 megawatt, right? It's not fully there yet. So it's almost like wondering how developers cope with this reality on the ground and as capital tightening meets this kind of hyper speculative demand that's out there, how are developers are navigating that in a safe way to have the underwriting skills for a deal like this? Maybe we
You
can
know,
talk about that.
yeah, it's interesting to talk about hyperscalers. So, um, I don't want to get out on a limb and claim I understand the economics of how they're developing those. I think it's quite a moment. It's one of those historical moments economically. You saw it around 2000 when they were building out the fiber for the internet, and then of course everyone got handed their butt in the end, and then it took 5 more years to reach what they had built out. I think there could be a scenario like that. There's a difference in that these guys, you take a Meta, you take some of those folks, they have a lot of money, and so maybe they're just going to be burning their own money. Probably not. What I would say is the reason that you're seeing so much hyperscaler activity and you're not seeing what would make a lot more sense, a distributed model of 50 to 100 megawatt data centers that could fit in the community. They wouldn't burden the grid. Those types of facilities would make so much more sense to our country. You could put one in every small town and increase their tax base and give some good jobs. And with dark fiber, it would work for latency. You don't see that because it's so hard to develop and diligence things that you have to have these massive, massive margins in order to pull it off and talk about hundreds and hundreds of millions and billions of dollars. And part of the reason you have to do that is because it's so hard to develop and diligence and get everybody on board to make something that is more reasonable work. And I know that personally because we're actually developing some smaller data centers and we're just focused on it. We don't care if it takes us 2 or 3 years. We're gonna propose to do it the right way. Our counterparties are going to have to sign agreements and are signing agreements. There's small towns and EMCs that say, okay, we're all in this together. We're going to have to change some utility law to make it work. Because it's so hard to, with all the layers and transaction costs and diligence paying around getting a smaller project with small margins done, even though it makes perfect sense. So you end up doing things that don't make a lot of sense because of how hard this process is.
And explain that to me. How are you basically foreseeing what goes into the data center, right? The semiconductors. You have to almost order them today, 2 years before the project is finished. How do you account for that to make sure these technologies you're ordering today are then still up to date in 2 years?
Well, that's part of a massive problem is if you take even a 50 megawatt data center, say, you're going to be around $13 million a megawatt in cost. So even a 50 megawatt center, you're up over $500 million. I mean, it's a big number. And somebody has to fund that. And meanwhile, tenants for compute or even giant tenants or for compute who are desperate really don't want to sign any kind of agreements over 5 years because nobody even knows what these chips will be in 5 years. Nobody knows how they'll be
Right.
structured. No, and so it's a real issue and it's a real problem. And um, I don't exactly know how it's going to get solved for a distributed model. I say we're working on it. It's going to take some utility change. It's going to take a lot of things are not happening in the market now. And so, my partners and I in East are resigned that it could be money we're spending, and it's significant money on the development side that does not actually come to fruition because of that. But we're making a bet that reason is going to have to prevail. Everyone is picking up their phone and using their AI. I mean, it doesn't appear that that's slowing down any. Unlike the internet thing I made reference to in 2000. At that point, it was a lot of hype, and it took a lot of time before everybody actually started using it. In this case, I think the demand will be there, and I think it has to be figured out. And I think you see all the moratoriums around the country. I don't think the populations are going to allow these endless hyperscalers. I think we're seeing
Right.
peak hyperscaler right at this point. And when these moratoriums, I think the last I saw, something like almost every state except maybe two has some sort of moratorium activity going on. I think reason's going to have to prevail just because communities are not going to allow these to be zapping the resources in their region.
Yeah, and I guess that there's a bit of a question mark around the demand side of things, right? I heard recently Alex Karp on Palantir on CNBC who want, okay, enterprises, corporations are a little bit wary about the data safety, right? Are they actually sharing alpha, as he called it, right? Their internal sort of secret source with these LLMs. And secondly, are they really willing to pay these billions for the tokens that they came up? And
Mhm.
why do they actually have tokens, right? If their technology is so groundbreaking, they would like to have a stake in that future billion revenue. Why would they even charge companies for that, right? I found that interesting as a perspective.
Yeah, absolutely. It's a wild space right now. I mean, at CERT we have a server investment and we're doing a lot of fine tuning on some models. And a lot of that is that concern about confidentiality and concern about, you made reference to LLMs and I think we'll talk about that in a little bit, but it's
Yeah, let's talk
interesting.
about that. I mean, the underwriting, right? Because that's some skill set that you're very involved in. Do you think LLMs are good for this kind of theory? Because I look at them and someone's like, okay, yeah, they give you confident answers, but are they really reliable in terms of checking an M&A deal or an underwriting deal, right?
Yeah. It's interesting. I think there's going to be a lot of learning. You're seeing some learning in legal, where lawyers are getting in contempt of court because they're getting sloppy with LLMs. I think you're going to see a lot of that in financial due diligence. It'll come out in different ways. Unfortunately, the pain comes out years later when you make a mistake there. But I've been amazed. I was at a conference the other day, and somebody from one of the major banks said, "Well, we just use Claude. I mean, that's
Right, a consumer LLM, we would call that, right?
we're safe. It's behind our firewall." Well, first of all, I don't really think commercial API firewalls are probably as secure as everybody thinks. The tendency to grab data is just too great. And so, I mean, there's a lot of work that we're doing on making sure, SOC 2 compliance and worrying about, people, the confidentiality of people's data, is an evolving space. And we just wanted to make sure we're out ahead of that there aren't any large language frontier models getting trained on our clients' data, because eventually that's going to bite you. You mentioned hallucinations. Yeah, we just had a huge debate in East because obviously we can't train a frontier model. That's not
Right,
we're not that type of business, but we can put a smaller model. We can put a Mistral model on premises behind a kind of impenetrable firewall, and we can fine tune the heck out of it. And we just had a debate on Friday, a bunch of very smart people in a room, and it was like, yeah, but if you don't use the LLM, yeah, it doesn't sound as smart when it talks. And I was
well,
like,
I
I
hear
could,
that a lot when I'm talking to people in different sectors, by the way. They talk to clients, and the client says, look, I'm using OpenAI, I'm using Claude. This needs to fit into my work stream, right? And then you guys have to make that happen, sort of give your proprietary system up for an LLM. How do you do that in practice to make sure it's not interfering with that data?
yeah, well, there's a lot of different ways to approach that. And I think like I said, it's going to be a moving space for a while. It is interesting to me how often we get, well, we're using we're using Claude, or we're using this or that. And without a lot of thinking about what that sort of means.
Right,
So, I mean, we do use frontier models. We're just very careful about where we use them, and we're very careful about what data goes into them, because there are times when there's a clear advantage. We're built though so that we can use any model. We can flip a switch and switch from OpenAI to Anthropic to because we're where we do use LLMs, we're very we're very neutral on which one it is. And I think as time goes on, some will get better than others, because the sort of the fastball of what we're doing is not based on the quality of the LLM. It's based on the level of sort of context graph and domain knowledge and understanding of all the interconnections and I use that in a different sense, but of all the interconnectedness of the components of an energy project. And
right.
the driver is not the AI particularly.
Yeah, and you know, when I listened to Alex Karp, he was basically saying the future seems to look like you're uploading a LLM or small language model into your system, and then it's done. You're not really constantly going back to the open system, right? So then the question comes, and of course Palantir is doing ontology. How do you charge then? Do you charge that by usage, or do you charge this on an ongoing annual basis to the client? Because
So
if I look at
yeah.
software, the software idea was always I develop it once and then there is massive scale because I send it out to millions of enterprise users, right? So the cost curve comes down, whereas with these frontier models, the cost curve goes up because the more usage, the more costs, right? That's why they're not profitable. How do you overcome that from a with third particularly?
Yeah. Well, if the most significant part of what we were doing was this compute, then I think we would be making a fundamental error, because yes, it's true. There's some compute that is used, and the way we use compute mostly is our diligence process is based on 900 questions that humans, when a lawyer and an engineer and a consultant is diligencing a project, it's based on what those humans would be asking. and we know what the answer should be for it to be a viable project. And so, yeah, are we using agentic AI? Of course, because it drastically speeds that up. But it's not, it's a very different thing than just throwing a huge data room at an LLM and asking it questions. That would be kind of a ridiculous platform, I think. It'd be more of a wrapper than an actual service that you're offering. So
Right.
we so compute is a small part of ours. We include the compute in the project cost, and then of course, if a user look, I'll give you an example. On our platform, you can make a podcast that describes your project. It's kind of a nice way to facilitate
Hmm.
information about the team, etc. Now, if you want to run that over and over and over with new scripts 30 minutes long, you're going to use a lot of compute.
Right.
That's a different type of burn of compute. And if you do that, you hit your limit and we have to pass the cost of compute on to you. But for the fundamental decisions you need to make and the information you need to get from a term sheet to a close, you'll be within the allowance we're giving you.
Right. And it depends on on how many documents you upload and so forth, but probably you don't even need a frontier model for that, right? Because as you say, these are standardized 900 questions and outcomes I can imagine some kind of risk scoring. So can you explain that a little bit further, how you come from the questionnaire to actually then give a score and move this forward?
Absolutely. So when you're starting with a data room, and as somebody who's done this for 25 years, data rooms are funny things. I mean, I've seen a lot of people's idea of what a professional data room is. And so data rooms can be quite a mess. Sometimes there's like five projects interspersed and thrown in there. Sometimes there's just sort of woeful lack of fundamental things you need in a data room. It really depends developer to developer, sponsor to sponsor. So the very first thing we do, and yes, we have to use some compute for this, is we take that data room, and we have seen data rooms that are just massive. And we realized it had everything in there down to the documentation of each solar panel on a gigawatt solar project. And so other data rooms, you might have 100 documents, let's say. Um,
Right.
we also see early stage pursuit data rooms that have three documents. And so we've kind of adjust to each one of those use cases. But the first thing we do is when we pull that data room in is we break it down and create a context graph and we create a structured data set out of that thing because a data room might have KMZ files and pictures and scanned PDFs that are messily scanned after somebody signed it. And there's just a huge variety of things you might see, emails that are saved, markdown files from some search. And so you really see a huge variety, and there can be a wide volume of that huge variety. So the very first thing we do is spend about 2 hours just crunching through what is in this data room. And so we can figure out how many is it several projects and do they need to be separated to get a decent analysis? Is it what stage is this in? Is this an operating project, which means it should check these boxes, or is it an early stage development, or is it right at NTP? The phase of the project, the state of the data room, all of that is things that need to happen so that you can fit it into sort of a larger context graph, a structured data set of what's going on. When we get that, at that point, we start in with these questions, which, like I said, are really sourced from 2 decades now of how humans do diligence a project. But the problem with humans is that there's a lot of scheduling and people are busy and they are fallible and there's an overlap and this law firm at the bank and this law firm at the private equity group and the sponsors law firm. There's just a lot of time and noise and scheduling that happen. And so really that's the after the structuring is the agentic AI just using these questions that are from the industry and knowing what they should say. And if the answer is different than that, they can then gauge. And then there's some rather sophisticated algorithms of how you would score risk on by those answers. And some sophistication in the agents, like if the answer is this, then it goes to this question. If the answer is this, it goes to this question. And so the thing really cascades into the CERT score, which is a risk score from 1 to 100, and it's broken down by components, which really are different pieces of a project, like the site and the offtake, et
Right.
cetera. And so each one of those gets its own score, and you get a score. And that way you're able to just quickly know the readiness of this project. And then you can quickly drill down to look, offtake is incredible for this project, but they don't have the EPC piece figured out. Or, you
Right.
really get a roadmap for what needs to happen to get that thing ready for a close.
So it really sounds your mode, if you will, your competitive enterprise value sits in logic and data, something I can't easily get out of a off-the-shelf LLM. So
Yeah,
I would need to come to
absolutely.
you because you spend a lot of time programming, coding that, and with so much capital not trying to find a foothold in this space. What do you think is CERT's underlying architecture that gives you that sustainable edge to make sure, there's not a Chinese competitor comes and gets your system for a couple of hours and then replicates what you've built there?
Yeah, it's there's several different things, we call that the moat, and there's several different things going on there. One is, we focus like a laser on this piece that is really from kind of just pre-term sheet to a financial close. I mean, that's what we do. We have a lot of competitors that we consider to be more adjacent in the space. They're a virtual data room that does some document analysis, there's a legal analysis, there's site location. But we have spent 3 years just focusing hard on this piece. And this piece is full of career-ending decisions if you make them wrong. I mean, so you have to be careful with your data, and you have to be careful with the quality of what you're doing to get that. And so we don't actually think you can just go recreate what we've done. And then on top of it, we started with a massive research project of every publicly available power purchase agreement and searches everywhere. There's not as many as you would think, though. There's not like you can just go crawl the web and find these. But we got enough to get started. And then we had some really good early pilot partners with hundreds of data rooms. And so we don't keep anyone's identifiable data, but we do extract anonymized data and benchmarks. And so we've been able internally to create our own. I think last time I looked, it was 34,000 documents, and growing rapidly, create our own data set that no other LLM has it. And so if you ask an LLM, is this a standard PPA? I don't care how powerful that LLM is, it doesn't have access to more than 1,000 of those in the world. And so we consider that to be the case. And we have just several other sort of fastballs you can't just go recreate. It's based on the fact that those of us that built this have done this for 20 some years. And if you think about this industry, we've done this for 20 some years, and there was barely an industry 20 some years ago. I mean, I told you about those first two projects I did, which were pitifully small. Those are actually, you should have seen the ribbon cutting on that 10 kW system. People acted like it was big. There wasn't a renewable power industry in 2003 when those of us that built this project started.
Very, very fascinating journey from solar panels over real estate, then to AI scoring systems. And
I would actually, I would change I'm an old guy. I did the 15 years of real estate before 2004, and since
oh, okay,
2000,
okay, okay, that
since
makes
since
sense. Okay.
2000, once I
From
became
bricks and
fascinated with
mortar
renewables.
over solar to AI scoring
Yeah,
systems.
once I became fascinated with renewables, it was all renewables.
Right, right. Well, fascinating discussion highlighting exactly, I think, why the industry is moving past off-the-shelf frontier models toward these kind of precise domain-specific intelligence you laid out for us, Rich. And moving capital faster, smarter requires exactly this kind of deep expertise. So thank you, Rich, and also thank you our audience for tuning in. And we look forward to continuing these vital conversations.
Excellent. Thanks so much. Much appreciated, Kenny.